just a comment, I forgot to mention it, but one of the reasons why we picked the Hubble Ultra Deep Field where it is that the Chandra Deep Field South area is close to the zenith of ALMA, and so ideally should be optimal for follow-up observations.
Yeah, that sounds great to do that.
Other questions or comments? Okay, I think it's time for coffee break. We'll be back at 4.
Okay. So I was given a brief to describe the multi-wavelength properties and kinematics of lens galaxies, which is a pretty tall order, given that we don't have a tremendously large number of them with this kind of detailed observation yet. And what I'm going to try to show is some of the details we do have, some of the value that has for us, and what the hypothetical instrument here from a publicity picture from maybe 5 years ago for the Atacama Large Millimeter Array shows, and then the site with one facility already operating on this 10-15 kilometer square plain in Chile where the ALMA is going to be built. And we'll be able to provide these things for us in great abundance, and there'll be beautiful pictures of high redshift galaxies and some of the same quality information that people were talking about earlier in the week from low redshift samples. So one thing I think I'm quite confident we still don't really understand is the details of how galaxy formation is taking place in situ at the high redshifts where it's taking place. We haven't got the quality of imaging and spectroscopy to really know what's going on in detail, and that's something which I think in the next 10 years we will have. We don't know the details between how mass and light are linked together in the triggering and formation of the most luminous, even the most luminous objects. We're not sure about how galaxies are modified by the local environment they're in at the time of formation. But lens galaxies is the ideal place to look, both from the enhanced flux from them and the boosted angular scale. And already there's possibilities for resolving material. We can see resolved images of HST, and Chandra can resolve away a point-like central object in a distant galaxy from X-ray binary emission associated with star formation in the deepest images. Integral field units are coming online in the infrared, some corrected and helped by adaptive optics. It's not great for arcs in clusters, which are probably the brightest distant galaxies we can probe, but they are good for individual distant objects, and that's something which is becoming an area that can be addressed directly to see the dynamics of those galaxies. And ALMA and also MIRI, I guess, on JWST, and NOSPEC on JWST will provide real details of the rotation, if it's present, the collapse, interaction going on in active regions in galaxies at high redshift directly. And I think ALMA, the details of it will be a tremendous transformative tool for this role, providing down to 10 milliarcsecond resolution, providing something of order of 50 to 100